This time I will. So it's about, this exercise is about, of course, a hydraulic lift. It says that I need to apply a force, and this force is of 950 Newton, and it's applied on the small piston. So in my hydraulic lift, in this, I will locate my force of 950 Newton. And as you can see, this force is coming down. Now, what do I know about this? I know that this large piston, because it says calculate the area and tell the radius of the large piston. So this is going to be my unknown. I need to calculate area and of course the radius of the large piston. So I wonder about this. I need to know area but also the radius, okay, of the large piston. I don't know what object is going to lift, but I know it should be capable to lift up to 3 metric tons object. Okay? Do you know what's that? Just in case that you don't remember, because I know you. 1 metric ton is equal to 1,000 kilograms. Okay? So, my hydraulic lift should be able to lift object of 3 tons or 3,000 kilograms. You do the conversion process if you want, okay, from tons to kilograms, you will see that the object that has to be lifted is 3,000 kilograms. So what do I need to know? I need to know the area and radius of the large piston. Now, the information given in the picture is that the small piston has a radius of 3 inches. Okay, that's what I know so far. So what should I do? Is a hydraulic lift, so I need to apply Pascal's principle. What is Pascal's principle? What is going to be my side 1 and 2? What is going to be my side 1 and 2? Urquilla, are you there? I don't see you. Joseph, Omer, Kenneth, Elmer, turn the cameras on, please. Okay, thank you. Okay, so when we talk about hydraulic lift, we need to apply Pascal's principle. Pascal's principle says that we are going to identify the side 1 and 2. My small side, I always call it side 1. And my large side, I call it side 2. That's just me. So I say, okay, I need to apply Pascal's principle. I need to know the pressures in the two sides. Pressure in 1 equals to pressure in 2. And I need to know, therefore, the force 1 divided by the area 1, or the force 2 divided by the area 2. Now, what information I have in the problem? I just have the force 1, that is 950 Newton. I can get the area 1 from the diameter, okay? What I need to know? I'm looking for the large area, okay? And also the radius, okay? It's related to the area 2. And I don't know the first 2, but I can get it from the weight equation, okay? So, what I'm gonna do? I will get what I need. I'm gonna get the area 1 and the force 2, which is exactly what I need to isolate then for the second area. So let's work on that. So my first step is going to be calculate the area, okay? For this area, I just know that the diameter is 3 inches, okay? So I'm going to convert these inches to meters. These are inches, and I say that in 1 meter I have 39.37 inches. How much you got? Two decimal places, please. And you can participate in the chat. 0.08 rounded, okay? 0.08 meters rounded. Now, from this, I can get the area. The area 1, therefore, because pistons, I told you, they are circular, you have to apply the formula of the area. That is pi radius of the side 1 raised to the second power. So this is pi times the radius. I don't have the radius, I have the diameter. So from the diameter, I need to get the radius 1, which is going to be the diameter 1 divided by 2, 0.08 meters divided by 2, which is 0.04 meters. So basically, this is the radius 1 that I was looking for, okay? So now I'm going to use this radius to find the area. Pi times the radius, that is 0.04 meters, to the second power. How much is this? Is this okay? Okay, scientific notation. Okay, scientific notation. Okay, yes, let's write this in scientific notation. So it's going to be 5.03 rounded. Times 10 to the negative third power. Okay, these are going to be square meters. We have the area. Now if we go back here to the main formulas, now I have the area. What do I need to get? I need to get the first two, okay? By using the weight formula. So that is going to be my second step. It says that the piston should be capable to lift 3 metric ton objects, and we didn't do the conversion. I mean, I did it mentally, but in your quiz or in your exam, you have to show all your work. So the procedure is going to be 3 ton. In 1 ton, you have 1,000 kilograms. Okay, not a big deal, but remember that you have to show all your work. So I know the mass of the object too. The mass that it should be lifted should be 3,000 kilograms. Okay, so from the first two, I'm gonna need to know the mass of the object 2 and gravity. The mass, we said that it should be 3,000 kilograms times 9.81 meters per second squared. Now with this, we go back to Pascal's principle, and now we know the first two. Okay, so now we are ready to isolate, to find the area 2, okay, and therefore the radius. So that's going to be my third step. I'm just gonna move these things from place. Okay, because I want to use the whiteboard like this. So my third step is going to be find the area, because the problem is asking me to find the area. So this is gonna be my third step. Find the large area, which is A2. So if I take my Pascal's principle, okay, I have this formula. If force 1 divided by area 1 equals force 2 divided by area 2. So I need to isolate area 2. So what I'm gonna do is I will cross multiply, okay, to isolate. So this cross multiplication is gonna give me force 1 times area 2 equals force 2 times area 1. Okay, I want to know area 2. So force 1, that is multiplying, is gonna go to the other side to divide. This one is multiplying, it's gonna go to the other side to divide. Okay, so my area 2 therefore is gonna be equal to force 2 times area 1 divided by force 1. And all I do now is substitution of your given. Okay, force 2, that is the one that we just got, that is 29,430 Newton, times the area 1 that we got, that is this one, 5.03 times 10 to the negative 3, square meters, divided by the first one, that is this one. I give it in the here in the word problem. It says it is a force of 950 Newton. So this will be 950 Newton. Here you cancel out the newtons. How much you got, you can write it in the chat. Zero point 0.16 square meters. Okay, 0.16 square meters. That is correct. But the problem doesn't say just find the area of the large piston. It says calculate the area and tell the radius. Okay, so what I'm going to do now, I'm going to find the radius that corresponds to that area. Okay, so I will transform this area 2 into the formula area 2, that is pi times radius 2 to the second power equals to 0.16 square meters. Okay, and then I will just make an isolation. Okay, pi is multiplying my radius 2, so it's going to go to the other side to divide. So my equation is going to be just the radius of the large piston raised to the second power equals to 0.16 square meters divided by pi. And to get rid of the second power, I'm just going to need to apply square root in both sides of the equation. So my radius 2, the formula of my radius 2 is going to be equal to the square root of 0.16 square meters divided by pi. How much is that? 0.23. Okay, the radius is going to be measured. Remember, here you're getting the square root, not just to the number, also to the unit. So the square root is going to cancel my square meters, okay? And they're going to become just single meters, okay? So, in order to lift an object of 3 tons, metric tons, I'm going to need a radius of at least 0.23 meters. That corresponds to an area of 0.16 square meters. And that will be the exercise. I don't know if you guys have a doubt on this exercise. Guys, do you have a doubt? But now, the other topic about fluids that we're going to be using is continuity equation. Now, I haven't given you the equation because it's very simple, but I just want to show you this. Okay, for continuity equation, we're going to need to know the formula. The formula is quite simple. The formula for continuity equation says that, well, the topic is continuity equation and flow rate, okay? Okay, this is the topic. Now, what do we need to know? Flow rate is going to be known as Q, okay? The flow rate is going to be denoted by the letter Q, okay? And the continuity equation is this equation that you see over here. That the flow rate in the large side of the pipe, in the small size of the pipe, is gonna be equal to the flow rate in the large side of the pipe. Now, what pipe are we gonna use as a reference? This one that you see over here is known as a venturi top, okay? A venturi top, sorry. And what do we need to know to apply continuity equation? We're gonna need to know, as you can see here, these are velocities, okay? We're gonna need to know velocities, and also we need to know the areas of the transsectional regions, which are, as you know, the pipes are circular as well, so we're going to be using a lot the formula to find the area of a circle. So, in this one, we're going to need to know not just the velocity, but also something to find the area of the pipe. For example, they could tell you the diameter or the radius, or directly they can give you the area, okay? It doesn't really matter. But also we need to know about velocities. But also Okay. Remember, conversions is always part of the topic. If a velocity is in kilometers per hour, you have to make, you should be able to make the conversion to meters per second. And why is that? By definition, flow rate Q is equal to volume per time. In other words, a flow rate measures the amount of volume that passes through a region in a certain time period. Okay, so for example, one way to what units do we use for volume? In what units do we measure volume? So for example, if I tell you to calculate the volume of this cube, what's going to be the volume? No. Volume is how much space an object occupies. Okay, for example, a cube. Okay, this cube over here has a length of 2 meters. Well, that's too big, okay? But anyway, this is just an example. So, how much volume it occupies? I mean, how much space? So that tells me that all this space that is occupied by this cube is going to be what we know as the volume, okay? Now, we obtain volume when we apply the formulas for them. In the case of a regular figure, the volume is when you multiply the 3 dimensions of the objects. In the case of a cube, the 3 dimensions are the same. This side measures 2 meters, this other side measures 2 meters, and height also measures 2 meters because it's a cube. All the sides are equal, okay? So in the case of a cube, to calculate the volume, you multiply L times L times L, okay? Which is 2 meters times 2 meters times 2 meters. Actually, there is a formula to calculate the volume of a cube that is L to the third power, which is the exact same. But all I want you to see is what units we're going to be using for volume. See? 2 and 2 makes 8. And when you multiply meters times meters times meters, it's going to give you cubic meters. So, to measure volume, we're going to be using the unit cubic meters. And what unit do we use to measure time? The SI unit is the second, okay? So, the unit that we're going to be using anytime we talk about flow rate is going to be cubic meters per second. Cubic meters per second. It can also be measured in gallons per minute, gallons per hour, cubic meters per hour, liters per second, liters per minute, okay? Those are also units to calculate the flow rate, to measure the flow rate, But the SI units are going to be cubic meters per second, okay? Cubic meters per second. Now let's work with the one example, okay? This is an example about conversion, okay? Q is equal to 25 gallons per minute. Convert this into cubic meters per second. This is just conversions, okay? I just want you to get used to it. The conversion is quite simple. You start with your given in the top. Remember that I always recommend to write ratios in the form of a fraction. So gallons is going to be in the top and minutes are going to be in the bottom. So What happens here? You need to know conversions for volume. Now, what conversions are we going to need? I'm going to write just the most important ones, okay? For example, in 1 cubic meter, you have 1,000 liters, okay? 1 milliliter is equal to 1 cubic centimeter. These units are equivalent, okay? What other unit do we have? Let's see. Gallons. Okay. 1 gallon is equal to 3.875 liters. What else do we need? Let me see. In 1 liter, you have 1,000 milliliters. Okay? And you already know the conversions for time. So if I ask you to convert 25 gallons per minute into cubic meters per second, so we can say that in 1 gallon we have 3.875 liters. Uh-huh. Let me confirm. Wait, let me confirm. Yes, it's true. 1.79. My dyslexia. It's not dyslexia. 785. I'm gonna do the correction here. 79 then. Okay, thank you. Then, what else do we need? We don't need liters, we need cubic meters. So, instead of liters, I need cubic meters. So, there are 1,000 liters in 1 cubic meter. So now you get rid of liters with liters. And then, I need to turn these minutes into seconds. Minutes are in my bottom, so now my minutes are going to be in the top. 1 minute, 60 seconds. Now you can get rid of minutes, and you perform all this conversion. How much is this? How much did you say, sorry? 1.58 times 10 to a negative third power, and these are going to be cubic meters per second. So keep those conversions in mind, okay, about yes, and make sure that you did this correction, okay, of the gallon and liters. And what else? Okay, also keep in mind the conversions of inches, okay, and the formula to find the area. Now, what is the continuity equation? Continuity equation is equal to the flow rate in the small area equals to the flow rate in the large area, okay? But we can also say that this is transformed into area 1 times velocity 1, velocity of my side, the small side, equals to the area of the large side multiplying the velocity of the large side. This is another way to see that flow rate has also this equivalence. Flow rate is equal to area times velocity. So imagine that I say that this, well, no, I'm not gonna have the time to develop one example of this topic, but at least you know another equivalence for flow rate. That is, flow rate equals to the area times velocity. If you're looking for the flow rate in the small area, so it's going to be flow rate 1 equals to the area 1 times the velocity in the side 1. If you're looking for the flow rate in the side 2, then it's going to be adapted to the larger side. Next class, I'm going to develop more examples about this topic and see that we're going to also use it with another equation. But so far, this is going to be it for today. I'll see you later in chemistry.